Welcome to the today's webinar on Ultra Ethernet Verification IP. Here is the agenda for today's webinar. Let's explore the TrueChip introduction and its P3 framework, a brief introduction about the Ultra Ethernet application use cases and its profiles, Ultra Ethernet verification IP overview, Ultra Ethernet VIP block diagram and its individual block features. Along with that, Ethernet VIP IP features, Ethernet VIP MAC and PHY features, Ultra Ethernet VIP GUI, and Ultra Ethernet VIP monitor and scoreboard overview. At final, let's explore one Ultra Ethernet sanity test case and its corresponding waveform, Ultra Ethernet test suits, Ultra Ethernet deliverables, and Ultra Ethernet VIP quality. Here is the introduction about TrueChip and its P3 framework. TrueChip is a leading provider of verification IP solution and design services. TrueChip is a P3 framework, proven solution, perfect integration and prompt support. TrueChip has direct sales and support presence across North America, Europe, and Asia. TrueChip has R&D centers in India and Vietnam. TrueChip is a provider of VIPs for Ethernet, PCI, USB, storage, AMBA, and many more VIPs. What is Ultra Ethernet? Ultra Ethernet is a next generation high performance Ethernet standard developed by Ultra Ethernet Consortium under the Linux Foundation. It is specially designed to overcome traditional Ethernet limitation to support high throughput, low latency for AI and HPC workloads. Ultra Ethernet specification version 1.0 enabling interoperable high performance Ethernet across the hardware stack. Ultra Ethernet core innovations. Ultra Ethernet transport layer with RDMA enhancements, flexible ordering, and packet spraying. In traditional Ethernet, if we use RDMA is layered on top, adding complexity and packet order must be handled by higher layers. But in Ultra Ethernet, RDMA is a natively enhanced multi-path delivery for efficient load distribution and tail latency reduction. In traditional Ethernet, all packets of flow follows one path, which leads to long tail latency. In Ultra Ethernet, multi-path delivery is possible, which leads to reduction of tail latency. Intelligent congestion control. In traditional Ethernet, even though we have TCP congestion, the feedback of congestion is very low. Whereas Ultra Ethernet has advanced algorithms NSCC, RCCC, TFC, which provides proactive congestion control to AI and HPC traffic patterns. Built-in high-efficiency transport layer security via IP security and hardware offload. Ultra Ethernet supports job-based security contacts to the transport layer itself. Ultra Ethernet scales to 1 million plus endpoints with minimal performance degradation. Traditional Ethernet provides thousands of endpoints which causes issues with congestion and routing management, whereas Ultra Ethernet provides 1 million plus endpoints with addressing and strong congestion management. Ultra Ethernet application use cases. Ultra Ethernet supports different application use cases, that is collective communications library, message passing interface, shared memory, unreliable datagram. CCL application typically involve reliable communication and matching based on sender ID, tagged message using exact matching without guarantees for duplicate tag. RMA write for data transfer, message and data ordering are not required and optional use of collecting offload is allowed. MPI application involve reliable communication and matching based on sender ID, tagged message with wildcard matching and duplicated tags alongside untagged messages. Here in MPI applications, RMA read is allowed along with RMA write for data transfers. Tagged message ordering is required. Though data ordering is not required, optional use of collective offload is allowed. Shared memory applications typically prioritize reliable communication with no message or data ordering requirements. RMA read, RMA write, atomic operations for data transfers and optional use of collective offload are allowed. UD are designed for unreliable unordered datagram communications for MPU sized messages. Message and data ordering are not required. Ultra Ethernet profiles. Ultra Ethernet specifies three profiles: A-base, A-full, and HPC to balance implementation complexity, cost, and capabilities for diverse workloads. A-base profile. It focuses on minimal implementation complexity to provide high performance for AI application at the lowest cost. Supported transactions are no operation, datagram send, write, immediate write, and non-fetching atomics. Supported addresses are relative and absolute. It supports RUD, ROD, and UED. Coming to AI full profile, it enhances AI base by adding features like deferable send, exact match, and support for atomic primitives. Supported transactions are send, tagged send, read, non-fetching and fetching atomics, and deferable send on both tag and untagged. Supported addresses are relative and absolute in AI full. Supports RUD, ROD, and UED. Coming to HPC profile, HPC profile addresses the needs of high performance computing application and is largely a superset of AI full and offering the most comprehensive functionality. Supports exact and wildcard tag matching for flexible message handling and support for rendezvous operations. Supports relative and absolute addressing schemes. HPC supports RUD, ROD, UED, and RUDI. Ultra Ethernet Verification IP Overview. TrueChip VIP compliant with Ultra Ethernet Verification version 1.0. It supports speeds from 100G to 1600G. The available in native Verilog, system Verilog languages with UVM, OVM, VMM methodologies. TrueChip VIP is compatible with Pentacosta, Credencency, and Synopsys PCS. Verification IP can be used for verification of Ultra Ethernet IP in a standalone or SoC environments. It supports all type of error injection and detection using layered monitors and scoreboards. On-the-fly protocol checking using protocol check functions. TrueChip callbacks in semantic and PDS sublayer to provide user control. Graphical protocol layer analyzer shows Ultra Ethernet data for easy debugging. Let's explore Ultra Ethernet VIP block diagram. This block diagram illustrates the architecture of our VIP. On the left, you can see the initiator side, which takes the AI workload sequence items and passes them through the Ultra Ethernet transport layer, which includes semantic, PDS, and congestion managements, and then through the IP DLL file layer to the target side. Crucially, our VIP includes the complete parallel monitoring task. We have dedicated monitors at each layer, 5, DLL, IP, semantic, PDS, and etc. This monitor passively checks for protocol compliance and feeds all transactional data into the central scoreboard. Scoreboard then compares the data sent from the initiator side with the data received at the target side, ensuring that end-to-end data integrity. Diving deeper into the layers, let's start with semantic sublayer. Semantic supports AI-base, AI-full, and HPC profiles. It supports both absolute and relative addressing. It supports message reasonable and packet fragmentation. Semantic supports semantic processing called buffer authentication, buffer authorization, and etc. It supports all types of sends, RMA operations, atomic operations, and rendezvous operations. Semantic supports configure MTU for the client's requirements. It supports response generation and response reception based on the packet transmission and receptions. Semantic supports completion queues to communicate with the upper layers. It can be configured for normal and error scenarios. TrueChip provides callback for user control. Next is package delivery sublayer. Our VIP supports all 4 delivery modes RUD, ROD, RUDA, and UED. We have implemented the fully functionality of the PDS manager, initiator, and the target state missions, including PDC establishment and closure. It supports robust loss detection and recovery using mechanisms like trimming, negative acknowledgement, and retransmission timeouts. It can generate all required control packets and supports the go backend mechanism for efficient recovery. It also handles UET CRC generation and checking. It can be configured for normal and error scenarios. TrueChip provides callback for user control. For the congestion management sublayer, our VIP provides comprehensive verification capabilities. It supports both network and endpoint telemetry for congestion feedback. We have implemented key algorithms like network signal-based congestion control, receiver credit congestion control, and transfer flow control. The VIP also supports ECN-based adaptive load balancing and packet spraying across multiple paths, which is a cornerstone for UET performance. It also correctly uses packet trimming to provide feedback to the congestion control algorithms. It can be configured for normal and error scenarios. TrueChip provides callback for user control. Security is a critical part of UET specification, and our VIP provides full support for the transport security sublayer. It verifies end-to-end confidentiality, integrity, and service protection for UET traffic. Our VIP supports the specific KDF algorithm, replay protection, symmetric algorithm, and proper TSS packet processing. It is also equipped to handle various security events and errors and supports both IPv4 and IPv6. It can be configured for normal and error scenarios. TrueChip provides callback for user control. Coming to the IP layer, IP supports the packet trimming, IPv4 and IPv6 packets. IP layer supports the checksum for error checking and padding if needed for transmission. It supports options with timestamps. IP layer also supports explicit congestion notification mechanism, which is vital for the advanced congestion control in UET. It can be configured for normal and error scenarios. TrueChip provides callbacks for user control. MAC and 5 features. MAC supports full duplex mode of operation connected to MAC client through TrueChip specific system interface. It interacts with the reconciliation sublayer with the help of standard PLS interface. It performs data payload framing, data padding, ASML, and FCS computation and checking. PMA provides loopback with corresponding PMA-PMD service interface. PMA supports bit-layer multiplexing and demultiplexing, clock generation and recovery. Callbacks in RS and 5 sublayer to provide the user control. It supports loopback in RS layer, performs 64B, 66B encoding and scrambling. It also supports alignment marker insertion, deletion, and block distribution. Ethernet VIP contains separate layered bus monitor for MAC, PCS, and PMA, which are easy to plug in and are compliant with standard specification. Ultra Ethernet VIP GUI. We know that debugging is one of the most time-consuming aspects of verification. To address this, TrueChip VIP enables easy debugging with the GUI tool. The GUI is created for both initiator and target separately. Transactions with the detailed descriptions of various block types. GUI is created for semantic and PDS transactions, also for easy debugging. GUI displays all the commands that occurred along with the type and their associated attributes. Ultra Ethernet VIP GUI model is compatible with the Linux and Windows. Let's explore Ultra Ethernet VIP monitor overview. VIP contains layered bus monitor, is easy to plug in and is compliant with the standard Ultra Ethernet version 1.0 specification. VIP has separate monitors for individual blocks mentioned here. Monitor gets full information about each transaction from the semantic interface and from the standard interface. Monitor flashes protocol violation as error with ability to log this information. It performs rich set of concurrent and immediate assertion checks. It contains auto masking feature for error injection performed using TrueChip callbacks. An option for static and dynamic masking for sequences will be provided. It contains functional coverage of all configurations. Monitor provides specific error ID for all the error messages with detailed description and spec section. Ultra Ethernet VIP scoreboard overview. Scoreboard ensures data integrity is maintained throughout the transfer. It inputs transactions from the device 0 semantics and compares it with the packets coming from device 1 semantics and vice versa. Here, device 0 and device 1 are the two instances or target or initiator. It is capable of logging all the information related to the message transmitted or received. Also, if any mismatches occurs, it flashes appropriate errors with their error IDs. Scoreboard capable of performing frame comparison in the initiator or target direction on the same channel. Ultra Ethernet sanity test case and its corresponding waveform. Here the few log prints from semantic block, which tells about how the response packet is transferring on logical interface from semantic to PDS. Right side picture tells about response is receiving from logical interface, which is coming from PDS to semantic block. Here the third picture tells about user configurable MTU 1024 bytes in decimal and request length of message is 4096 bytes in decimal. These are the few more log prints from the PDS block, where the packet is driving based on the NICC algorithm is allowing or not. Here is the few terminal logs which tells about how message is processing in semantic block and how packets are transmitted by PDS block. Here the semantic is processing message with request length 4096 into 4 packets. Here the 4 packets are divided based on the configurable MTU value 1024 bytes in decimal. Semantic is transmitting the first packet with corresponding message ID 8458. Here the PDS is transmitting data packets with corresponding packet sequence number. Let's observe the waveform, how packets are transmitting from semantic block to PDS block. Here we follow the order delivery. So the packets will go in the sequential manner. Here the start of message indicates that it's the first packet is transmitting from semantics to PDS. And end of message indicates that this is the final packet that is transmitted from semantic block to PDS. And corresponding message job IDs are driving according to the corresponding packets. So along with that, there are RX fields, which is a packet is receiving based on the start of message and end of message. Along with the packet transmission and reception, there is response transmission and reception also is there. Here we can observe how response packets are transmitting and how the response packets are reception is happening. Another waveform tells about how packets are driving on logical interface. Here there is separate individual variables called start of message, end of message, indicates where the packet is starting and where the packet is ending. And its corresponding values tells about how packets are driving based on that message ID, job ID, and packet length, and so on. This waveform tells about how PDS is transmitting packets based on the packet sequence number and its corresponding variables. These are the RX fields, how the packet is receiving in the PDS blocks based on the packet sequence number and its corresponding variables. Ultra Ethernet test suites, basic and directed test suite. The basic test suite contains the basic directed test cases required for the basic flow and functionality of each component. Random test suite. This test suite contains randomized test case required for the complete functionality and corner case sets. Error test suite. This suite contains the test cases needed for deliberate error injection. Assertion and cover point test suite. This test suite contains test cases required to cover all the cover points and assertions. User test suite. The user can write their own test cases either by expanding the existing sequences or by writing new sequences and corresponding test case. Also, the user can request the design of sequences and tests for targeted scenarios as per his requirement. Ultra Ethernet deliverables. The deliverables includes initiator and target models for speeds up to 1600 G. User will receive bus function models or agents for every single layer of the stack from semantic and PDS down to PMA and AN. The package also includes a comprehensive layered monitors and scoreboards that we discussed, a comprehensive test environment, and all the test suites we just covered, the basic random, user-defined, and the error scenario test cases. Along with the VIP code and test suites, we provide extensive documentation to ensure a smooth integration and user experience. This includes an integration guide for out-of-box testing and integration, a quick user guide, a detailed user manual covering all configuration and test suites, a comprehensive test plan, and release notes with every new version of this product. Quality of VIP. All VIPs come with a comprehensive set of assertions. VIP has extensive test and coverage plans. All VIPs have strong protocol checking monitors. All VIPs are tested with all industry-leading simulators. VIPs are coded in SVN with UVM, which makes VIP lightweight. All VIPs are being used in production by various customers. The VIPs provides a wide range of error injection scenarios to stress test the DUT. TrueChip bug tracker system for prompt support. On-site support for customers in India and support over bug tracker, calls, screen sharing, and VPN. Thanks for attending the webinar.